Let's do just a really quick review of radians. In my unit circle, I know that the full rotation is equal to 2 pi radians. So that would be pi. This would be pi over 2 and 3 pi over 2. Okay. Where would 8 pi over 7 land? Not 4, 3. Why 3? It's a little bit bigger than 1 pi. So if I were to do that rotation, 1, 2, 3, 4, 5, 6, 7 sevenths, that would be 8 pi over 7, just a little bit bigger than 7 pi over 7. Okay, what about 5 pi over 3? Where's that going to land? 4. It's bigger than 1, but it's actually closer to 2 pi. So that would be over here in quadrant 4. Okay, what about negative 2 pi over 5? Where's that going to land? We have to go backwards, so we're going to rotate in this direction. It's in the 4th because it's less than 1, but it's closer to 0 than it is to 1. Does everybody understand that? So it's going to be over here in quadrant 4 somewhere. Okay. Now, what is the definition of a radian? A radian is the distance traveled around the circle in terms of the radius. So you have your circle, however big it is, and you basically cut a string that is equal to the radius. And then you use that radius to measure the length around the circle. So whatever your length of your radius is, we just call it 1 radian. And then I take that string and I lay it across, and when I get to 1, that is called 1 radian, which is about, I think it's about 58 degrees. 53, 58, can't remember. Somewhere in there. So a radian is not really a rotation, it's a distance. It's the distance traveled around the circle in terms of the radius. And the nice thing is, for big circles and small circles, the angle is the same. Okay, well, how many radians are there? 1, 2, 3, 4, 5, 6, and a little bit. Because the circumference of that circle is 2 pi radians, which is 6.28 radiuses. Radiuses, something like that. So every circle has a circumference that is equal to 6.28 2 or 3, whatever, yeah, right, times pi by 2. That's how many radiuses are in a circle. Now, we never use the decimals for radians. You can, but we just leave it in terms of pi. Pi over 2, 3 pi over 2, that sort of thing. Okay? Now, the nice thing is, if you want to calculate the arc length of a circle, radians work beautifully. So if I want to know, I have an angle, I want to know what is the distance of that arc. Well, I need to know the angle and how big the radius is. If I know that, then I can find the arc length really easily. In degrees, it's kind of difficult. So let's say this is 80 degrees. And my radius is 4 feet. Well, to calculate the arc length, we need to figure out how much of the circle we're using. 80 degrees is what percentage of the circle? One of these is my calculator. Maybe. It let me down. Oh, there it is. It just appeared. So 80 out of 360 degrees is 22.2%, right? And the circumference of the circle is 4 times 2 times pi. And now I need to multiply that by 0.22. And I get an arc length of 5.5 feet. That was kind of annoying. I had to figure out 80 degrees is what percentage of the circle. I had to figure out the whole circle and then multiply by the percentage. In radians, it's super easy. Um, what is that in radians? So this is 4 pi over 9. 4 pi over 9 is the angle in radians. All I have to do is times this by 4, and I get the arc length. So that gives me 16 pi over 9. So, right, if they give you the angle in degrees, you convert it to radians, which is essentially what I did up here. You can't really see it inside the calculations, but that's basically what I did. The nice thing is, nobody in their right mind would ever calculate arc length using degrees. And I believe in the book, you just get radians. And you'll notice 16 pi divided by 9 happens to be that exact number. So on your assignment, 81 through 87, find the exact length of the arc made by the indicated central angle and radius of the circle. So all you do is theta times r. That is the arc length formula in radians. In degrees, it's more complicated. You have to times it by pi and then divide it by 180. Okay? And then the next set says, find the area of the circular sector given the indicated radius and central angle. Hi, guys. Sorry. Yeah, don't worry about it. You're fine. So, arc length is easy. And I believe arc length is always lowercase s. I believe that's the variable for arc length. Arc length is r times theta. What if I wanted the area of this piece of pizza? How am I going to figure that out? Well, what's the area of the whole circle? Did we not tell you? Sorry. So, what is the area of the entire circle? What's the area formula? Pi r squared. So the area is pi times 4 squared. Okay? How much of that area am I using? 22.2%. How can we figure that out in radians? Well, I'm using 4 pi over 9 out of 2 pi. So if I did 4 pi over 9 divided by 2 pi over 1, I invert and multiply times 1 over 2 pi. The pi's cancel, and I have 4 over 18, which simplifies down to 2 over 9. What does 2 over 9 tell me? That is the fraction of the circle that I'm using. This pizza is 2/9 of the circle. So if you cut the pizza into 9 pieces, this is 2 of those pieces. Okay? So what do I do with 2/9? I times it by the total area of 16 pi times 2/9. And that gives me 32 pi over 9. And then that would be square feet. Okay? There's got to be an easier way to figure that out, right? So let's do this in a generic form, which is something you guys kind of need to learn. Theta and r. Here's a circle. I have no idea how big the circle is. I have no idea how big the angle is. Okay? Let's create a formula that will give me the area of this piece of pizza. Well, what's the area of the entire pizza? Pi r squared. So area equals pi r squared. Okay? How much of that pizza am I going to use? Theta. Right? So the full pizza is 2 pi, and I'm going to use this much of it. So the percentage is theta over 2 pi. Does everybody understand that? What do I do with this number? Times it by the area of the entire pizza. So I take the sector area. This is called a circle sector. The sector area is the total area, pi r squared, times the percentage according to theta, which is going to be theta over 2 pi. And what happens? The pi's cancel, and I get r squared theta over 2. That formula will calculate the area of any piece of pizza if you know how big the angle is in radians. It doesn't work in degrees. And how big the radius is. Now let's double check. Yeah. Yep. So look at page 429. In the top box, arc length is r theta, which only works in radians. In the bottom box, the area of a circular sector is 1/2 r squared theta. And once again, each of these formulas only works if your angle is in radians. If it's not in radians, then you convert it to radians. And if you were to look at the formula for degrees, it would look like this. So the area in radians is 1/2 r squared theta. This is in radians. And the area in degrees is this, 1/2 r squared theta times pi over 180, which is just the conversion from degrees to radians anyway. All right. Linear speed, really? That must, if I kept it in there, it must be part of the final. Okay. All right. Linear speed. So number 96 says find the linear speed of a point that moves with a constant speed in a circular motion if the point travels along the arc S in time t. So we have a circle, and we have an arc length of 12 feet. And to traverse that arc, it takes 3 seconds. 3 minutes? No, sorry. 3 minutes. Do we know how big the circle is? We don't, right? This 12 feet might be almost the entire circle, or maybe it's a tiny part of a huge circle, and theoretically, it could even be multiple laps around a very small circle. So if this point travels 12 feet in 3 minutes, how fast is it moving? Well, rate times time equals distance. What do we need to do to that equation? Solve for r. So r equals d over t. So 12 feet in 3 minutes simplifies down to 4 feet per minute. And I assume you're just going to keep the units that are given. So 97 will be kilometers per hour, 95 will be meters per second. Yep. Okay. Find the distance traveled of a point that moves with a constant speed v along a circle in time t. So for 90, let's do 100. So the velocity, or the rate, let's just call it rate, is 6.2 kilometers per hour, and the time is 4.5 hours. To calculate the distance, we use that same formula, rate times time equals distance. So we're going to do 6.2 kilometers per hour times 4.5 hours. Hours cancel hours. And 6.2 times 4.5 gives me 27.9 kilometers. Yeah, so r is the rate, v is the velocity, and they're kind of the same thing. Velocity also includes a direction. Yeah, yeah. So we're just going to be using this formula here. And in this case, you just multiply them together. All right. So 104, find the angular speed. What does angular speed mean? It will involve radians. Close. So let's say you attached a rope to a motorcycle and you told the motorcycle driver, just drive. Okay? That motorcycler is just going to go around in circles, right? So the speedometer on the bike will tell you your linear speed, even though you're not traveling in a straight line, right? The speedometers always tell you linear speed, even when you're turning. That's how fast the car is going if you were going straight, right? Angular speed is different. Angular speed talks about how fast you complete your rotation. What is the angular speed of the Earth around the sun? It would be you do one revolution in 365 days, which, by the way, is where we get the degrees equal 360. Did you know that? 1 degree is about the distance that the Earth travels from here to here in 1 day. So why did we pick 360 instead of 365? 360 has a lot of factors. 365 is not divisible by many numbers, but 360 has 2, 3, 4, 5, 6, 8, 10, 12, 15, 18. All of those go into 360, which means our fractions, we have fewer fractions because we have more factors. So 360 is a nicer number than 365. Also, if we used a base 12 system instead of a base 10 system, half of our fractions would disappear. Because 10 is only divisible by 2 and 5. But 12 is divisible by 2, 4, 2, 3, 4, and 6. So why did we pick a base 10 system instead of a base 12? Because some groups did use base 12, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you'd have to have another. People just did, but we we had 10 fingers, so that's why we ended up with a base 10. But if we would have chosen a base 12 system, we would have half the fractions that we have now. So base 12 would be really nice. Yeah, because dozens make a nice rectangle, right? 10 does not make a very nice rectangle, 2 by 5. But a 3 by 4 rectangle is a lot easier to use. So, yes. Okay, so back to this. As this motorcycle travels around the circle, the speedometer will tell you how fast the bike is moving linearly. But how fast is it going according to angles? Okay, so if this is a really big circle, then you might do something like 1 degree of rotation every hour. Does that make sense? If this is an enormous circle, it might take us 1 hour to do 1 degree of rotation. That is called the angular velocity. How fast do the degrees change? Well, what if you can do a whole lap in a minute? Then how fast is your angular rotation? 360 degrees every minute. Okay? So to find the angular velocity, you have to figure out how fast the angle is changing, not how fast the position is changing. So for number 104, we are going to do 3 pi over 4 radians in a sixth of a second. Where is 3 pi over 4? It's almost 1, so that puts it in quadrant 2. So this much of a rotation occurs in 1/6 of a second. So rate times time equals distance. We know how far we traveled, and we know how long it took to get there. I need to find the rate, so that's just going to be d divided by t. So 3 pi over 4 radians, and I'm actually not going to write radians, divided by 1/6 of a second. What do I do? Invert, multiply, 6 over 1. So 3 times 6 is 18. So 18 pi over 4 radians per second. We simplify that down to 9 pi over 2 radians per second. What does that mean? So in 1 second, what's going to happen in this circle? Where is 9 pi over 2? 9 pi over 2 radians. Pi over 2 is this far. So 9 pi over 2 would be 9 of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was 4¼ revolutions. Let me check that again. So this is, so it's, so this is pi over 2. This is 1 pi, and this is 2 pi. 9 over 2 is 4.5 pi, right? So you can either count it in pies, 1, 2, 3, 4 and a half, or you can count the halves, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2½ revolutions per second. That's the angular velocity. Okay, and how far do you need to go? 113, okay. The next one, find the linear speed of a point traveling at a constant speed along the circumference of a circle with radius r and angular speed w. Okay, so for this one, let's do 108. 3 pi over 4, and the radius is 8. Oh, this is radians per second. So we do 3 pi over 4 radians per second, which means I rotate this much, 3 pi over 4, every 1 second. Okay. And we want to find the linear speed of that point if the circumference of the circle is 9 inches. How do we figure that out? So the speed is 3 pi over 4 radians per second. And the radius of the circle is 8. How fast is the speedometer on the motorcycle? Well, it covered this distance in 1 second. So we just need to figure out what that distance is. It's just so rate times time equals distance. I know the rate and I know the time. Or sorry, I know the rate. I know the rate. I need to figure out the distance using the time of 1 second, which is just the arc length, right? How far is it from here to here? That's just the arc length formula. S equals r theta. So you just multiply these together and you get, what's that? This is 107 and 109. Yep, 3 pi over 4 radians times 8. All right, and lastly, find the distance a point travels along a circle over a time t with the angular speed w and radius of the circle. So the radius for number 112 is 2, and the angular speed is 6 pi radians per second, and we're going to travel for 11 seconds. You need to find the distance. So we know how fast it's, we know how big the radius is, we know how fast it is spinning, and we know how long it's going to spin. How are we going to calculate the distance traveled? It's just going to be all of those multiplied together, right? Because 6 pi is our angle per second. So 2 times 6 pi will tell us how far we've traveled angle-wise, and then multiply that by 11, and that's going to be how far we travel in 11 seconds. Yep. Good luck.